Welcome to our deep dive into interactive machine learning.
Or IML,
Yeah,
as it's often called.
IML. We're going to be unpacking a research paper today
Okay.
that you sent my way.
Yeah.
It's titled Interactive Machine Learning, a state-of-the-art review.
Yes, a very timely paper.
And this paper digs into, the current landscape of IML.
It does.
And over this deep dive, I was hoping we could try to explore its key benefits,
Sure.
the really, interesting real-world examples.
Yeah.
And maybe even touch on what the future might hold for this, really exciting field.
It's a comprehensive review, and it nicely starts off by making a really clear distinction between, traditional machine learning
Right.
and IML.
Okay.
And as you know, in traditional approaches, we
Right.
kind of treat the model as a black box.
Yeah.
Right? There's limited human interaction during the training process, and this can lead to several challenges.
So, like,
Fine.
understanding why a model makes certain predictions.
Exactly.
I can see how that could be a problem, especially in, some of these really high-stakes applications.
Absolutely. And even beyond the explainability issue.
Yeah.
Traditional methods often require massive data sets
Yeah.
and huge processing power,
Right.
which isn't always feasible or practical.
Yeah, especially for, smaller companies or
Yeah.
anyone without those massive resources.
So that's where IML steps in.
Okay.
The core idea of IML is to put the human in the loop.
Okay.
You're not just a beta provider.
Right.
You're actively shaping the model.
So instead of just, feeding data to an algorithm,
Right.
IML kind of involves this more collaborative approach.
Yeah.
Where humans and machines work together to build, more robust
Yeah.
and trustworthy models.
Precisely. The paper highlights 3 major benefits of this interactive approach: robustness,
Okay.
trustworthiness, and low resource learning.
Okay.
Let's start with robustness.
Okay.
The authors point out the growing concern of adversarial attacks, where subtle manipulations of input data can fool even the most advanced algorithms.
It's almost like tricking the AI into
Yes.
seeing something that isn't really there.
Yeah.
I've read about those cases where,
Yeah.
image recognition systems are fooled by adding tiny,
Right.
almost imperceptible stickers to stop signs.
Absolutely.
It's a little unsettling
It
to
is.
think about the potential consequences, especially as these, AI systems are becoming increasingly integrated into our lives.
Yes, the real-world implications of such vulnerabilities are significant.
Yeah.
You think about autonomous vehicles or medical diagnosis systems being misled by these attacks.
Yeah.
The consequences could be catastrophic.
Absolutely.
And the paper discusses how IML offers a powerful defense mechanism against these adversarial attacks.
Okay, that's interesting. How exactly does IML help in defending against these attacks?
So the paper discusses 2 primary ways: visualization tools and proactive defense. So visualization tools help us understand how an attack affects the model.
Okay.
For example, they mention a tool called MASEF,
Okay.
which allows you to visualize how an attack impacts the activations of different neurons in a deep learning model.
So it's like having a microscope that lets you look inside the AI's brain
That's a good analogy.
and see how it's being manipulated.
Yeah, it's a powerful way to understand these attacks
Yeah.
and then develop strategies to mitigate them.
That's really incredible.
And then there's the proactive defense approach.
Okay.
By building models interactively from the start,
Right.
we can make them inherently more robust to these attacks.
Makes sense.
Imagine a human expert guiding the model during the training process,
Right.
identifying and correcting potential vulnerabilities along the way.
So if the human is involved in every step of the learning process,
Yeah.
it'd be much harder for an attacker to, exploit any hidden weaknesses.
Exactly. And the paper even highlights Angloin's equivalence query model as an example. In this approach, the human expert interacts with the model during training, providing feedback and corrections that help the model learn more effectively.
Okay, so let's move on to the next benefit you mentioned,
Sure.
trustworthiness.
Right.
This one seems particularly important as AI is being used in increasingly sensitive domains
Absolutely.
like healthcare and finance, where trust in the system's decisions is paramount.
Absolutely. One of the biggest challenges with traditional machine learning is this lack of transparency,
Right.
right? We often don't know why a model made a particular prediction,
Right.
and that can make it difficult to trust its outputs.
Yeah, absolutely.
IML addresses this challenge by focusing on explainability.
So we're not just looking at the final output of the model,
Right, yeah.
but also understanding the reasoning behind it.
Precisely.
Okay.
The paper discusses various IML tools and techniques designed to make models more transparent and explainable.
Okay.
For example, there's AAPI. This is a system that provides visual explanations for any type of machine learning model.
That sounds really useful.
Yeah.
Especially for, non-technical users who may not be familiar with the intricacies of machine learning algorithms.
Absolutely. And the paper also highlights specialized systems like decision trees,
Okay.
where the decision-making logic is explicitly laid out
Right.
in a way that is easily understandable even for those without a deep understanding of AI.
It's great that IML can provide these different levels of explainability.
It is.
It makes me think of a toolbox
Yeah.
where you can choose the right tool depending on the level of detail
Exactly.
and transparency needed for a particular application.
That's a good analogy. And there's interesting research
Yeah.
highlighting the benefits of IML for explainability in robotics.
Okay.
They did a study comparing autonomous robot search plans,
Okay.
and IML resulted in more explainable plans.
Interesting.
Even though humans initially had more trust in the black box models.
Oh.
This likely reflects the influence of pre-existing biases towards opaque but seemingly sophisticated algorithms.
That's a fascinating point. It seems like IML can help overcome those biases
It can.
by making the reasoning behind an AI's actions more transparent.
Exactly.
I'd love to hear more about the specific tools and techniques
We can definitely delve deeper into those as we continue.
used in that research.
Yes.
Yeah.
Another example highlighted in the paper is Elastic,
Okay.
an IML tool designed for image analysis, particularly in healthcare settings.
Okay.
It really demonstrates the power of IML to achieve both speed and usability without compromising accuracy.
It sounds like Elastic is a great example of how IML can be tailored to the specific needs of a domain,
Exactly.
providing a user-friendly interface while still maintaining the rigor required
Yeah.
for medical applications.
And that brings us to the third key benefit of IML,
Okay.
low resource learning.
Okay.
This is where IML truly shines because it can be incredibly effective even when we don't have access to vast amounts of data.
I can imagine that being a game changer in fields where data is scarce or expensive to collect.
Absolutely.
What are some of the areas where IML is making a difference in low resource learning?
So one of the early success stories for IML was in machine translation, especially for languages with limited digital resources.
Okay.
Imagine a human translator working alongside a machine learning model,
Right.
guiding its learning process and maximizing the value of each translated sentence.
That's a great example of how human expertise can augment the capabilities of a machine learning model, especially when dealing with limited data.
Absolutely. And beyond machine translation,
Yeah.
the paper highlights other applications of IML in low-resource settings,
Okay.
including image processing,
Okay.
search engine optimization, and even pattern mining in social networks.
It's fascinating to see how versatile IML is. It seems like it can be applied to such a wide range of problems, regardless of the amount of data available.
It is.
Are there any specific examples mentioned in the paper that illustrate these diverse applications?
They discuss a tool called Regroup,
Okay.
which allows users to create custom contact groups.
Okay.
It uses IML to identify patterns in user interactions and then allows users to refine those patterns through interaction.
So it's like having an AI assistant that can help you organize your contacts based on your specific preferences.
Exactly.
That's really cool.
And the paper even delves into the use of IML in creative fields like music and games.
Okay.
They mention SketchRun,
Okay.
which helps users draw by understanding and predicting their strokes.
So instead of just being a passive tool,
Yeah.
SketchRun actually learns from the user's drawing style and becomes more personalized over time.
That's right. And there's also the Wekinator, which enables real-time musical interaction powered by machine learning.
Wow.
It's an exciting example of how IML can blur the lines between human creativity and artificial intelligence.
It's incredible to see how IML is being used in such a diverse range of applications.
Yeah.
From ensuring robustness against adversarial attacks to enabling low-resource learning and even fostering creative exploration.
It is.
It seems like IML is poised to transform the way we think about and interact with AI.
Yeah.
But I'm curious, with all this human involvement, how do we measure the effectiveness of IML?
That's a great question.
Do we just rely on, traditional performance metrics?
That's a great question, and the paper addresses it directly.
Okay.
Traditional performance metrics, which focus solely on algorithmic accuracy, might not be sufficient
I see
to
that.
capture the nuanced interplay between humans and machines in IML.
Yeah, it's not just about how well the algorithm performs in isolation,
Yeah.
but also how effectively it collaborates with the human expert.
Exactly. We need new ways to evaluate IML systems, taking into account both the algorithm's performance and the quality of the human-machine interaction.
Like what?
Well, there's EvoGraph Dice,
Okay.
which combines traditional algorithmic evaluation with a human-centered perspective. It's designed to assess how both the algorithm and the human adapt and learn during the IML process.
That sounds promising. It seems like a more holistic approach to evaluation that considers the dynamic nature of the human-machine partnership.
It is.
Are there any other examples mentioned in the paper?
They also discuss NFUs,
Okay.
a method that lets you rank features based on both algorithmic performance and expert judgment.
Okay, so it's not just about blindly trusting the algorithm's choices.
Right.
NFUs provides a way to incorporate human domain knowledge and ensure that the model is prioritizing the most relevant features.
Precisely.
Gotcha.
Evaluating IML is an active area of research.
Yeah.
And developing robust and reliable evaluation methods is crucial for demonstrating the value of IML and guiding its future development.
Absolutely. We'll delve further into these evaluation challenges in the next part of our deep dive.
Sounds good.
It seems like we've covered a lot of ground already, exploring the key benefits of IML and some really compelling examples of its real-world applications.
We have, but the paper goes beyond just listing the advantages. It actually presents a structured taxonomy of IML research,
What?
which is really helpful in understanding the different dimensions of this field.
A taxonomy.
Huh?
That sounds interesting. What's the framework they use to categorize IML research?
They propose a merit-oriented architecture,
Okay.
which essentially organizes IML research based on the specific benefits it offers.
So the three major benefits we've been discussing: robustness, trustworthiness, and low-resource learning.
Right.
Those form the foundation of this taxonomy.
Exactly. Those are the core merits of IML,
Okay.
and they represent the high-level categories.
Gotcha.
Then within each of these categories,
Yeah.
the paper further classifies research based on its technical and sectoral focus.
Okay. I'm starting to see how this taxonomy helps organize the vast landscape of IML research.
Yeah.
So on the technical side, what are some of the key areas of focus?
So the paper highlights several important technical aspects.
Okay.
First, there's human-computer interaction, HCI. This area focuses on designing intuitive and effective interfaces for humans to interact with IML systems.
Makes sense. If we want humans and machines to collaborate effectively, the interface needs to be seamless and user-friendly.
Absolutely. Then there's visualization.
Okay.
This involves developing techniques to present complex data and model behavior in a way that's easily understandable to human experts.
Right.
Visualizations can play a crucial role in making IML systems more transparent and interpretable.
It's like giving the human expert a clear window into the inner workings of the AI system.
Exactly.
That's essential for building trust and understanding.
And of course, there's model explainability, which we touched on earlier.
Right.
This area of research focuses on developing methods to make the decision-making process of IML models more transparent.
Right.
The goal is to enable humans to understand why a model made a particular prediction, not just what the prediction is.
So it's about moving beyond black box AI and making the reasoning behind the model's decisions accessible to human experts.
Precisely. Now, shifting to the sectoral focus, this is where we see the real-world impact of IML.
Yep.
The paper provides a comprehensive overview of how IML is being applied across various sectors, from agriculture to healthcare to education,
Wow.
and even to entertainment.
It's fascinating to see how IML is being tailored to address the unique challenges and opportunities in each of these domains. Could you give us some specific examples?
Certainly, in agriculture, IML is being used for tasks like crop disease detection and yield prediction.
Okay.
Imagine farmers working alongside IML systems to optimize their crop management strategies,
Right.
leading to increased productivity and sustainability.
That's a great example of how IML can empower domain experts with the insights they need to make better decisions.
In healthcare, IML is playing a crucial role in medical image analysis.
Oh.
For example, radiologists can use IML systems to analyze medical scans, helping them detect anomalies more accurately and efficiently.
And I can see how IML's focus on explainability would be particularly important in healthcare. Where the stakes are so high, it's not enough for the AI to make a prediction. We need to understand why it arrived at that conclusion.
Exactly. And beyond these specific applications, IML is also being explored in areas like personalized education.
Okay.
Imagine IML systems that adapt to individual students' learning styles and provide customized feedback, leading to more effective learning outcomes.
The possibilities seem endless. It's clear that IML has the potential to revolutionize many different sectors. But as promising as IML is, the paper also acknowledges that there are still significant challenges in areas where further research is needed.
Absolutely. The authors highlight several key challenges,
Okay.
including the need for more robust defenses against adversarial attacks. As IML systems become more integrated into critical applications, ensuring their security and resilience against these attacks becomes paramount.
We can't rely solely on human oversight to prevent these attacks. We need to develop more sophisticated techniques to safeguard IML systems.
Another challenge lies in managing the human element of IML. How do we ensure that humans are appropriately engaged in the learning process without being overwhelmed or introducing their own biases?
It's a delicate balance.
Yeah.
We want to leverage human expertise, but we also need to be mindful of potential pitfalls.
Precisely. The paper also emphasizes the need for more research on low-resource learning.
Right.
As we discussed earlier, IML is particularly effective in situations where data is scarce.
Yeah.
But we need to develop even more efficient techniques to push the boundaries further,
Okay.
especially in fields like robotics and pervasive computing.
So even though IML has already shown great promise in low-resource settings, there's still room for improvement,
There is.
particularly in domains where data collection is challenging.
Exactly. And as we discussed before, evaluating IML presents a significant challenge.
Right.
Traditional metrics might not be sufficient to capture the complexities of human-machine collaboration.
Yeah.
We need new methods and frameworks to assess the performance of IML systems accurately and comprehensively.
So it's not just about measuring the accuracy of the algorithm, but also understanding the quality and effectiveness of the interaction between humans and machines.
Precisely, this involves considering factors like the clarity of the interface, the interpretability of the model's explanations, and the overall user experience.
It seems like evaluating IML is a multifaceted challenge that requires a more holistic approach than traditional machine learning evaluation methods.
Absolutely. And finally, the paper emphasizes the importance of user experience in IML design.
Okay.
Developing IML tools that are intuitive, user-friendly, and enjoyable to use is crucial for wider adoption.
That makes sense. If IML systems are too complex or difficult to use, people will be hesitant to embrace them no matter how powerful the underlying technology is.
Exactly. The authors advocate for incorporating human-centered design principles in IML development, ensuring that these systems are tailored to the needs and capabilities of human users.
So it's about striking a balance between technological sophistication and user accessibility.
Precisely. The key takeaway from this section is that while IML offers tremendous potential, there are still significant challenges to overcome. Addressing these challenges will be crucial for realizing the full benefits of IML.
It's clear that IML is a rapidly evolving field with a lot of exciting research happening. It will be interesting to see how these challenges are addressed in the coming years and how IML continues to shape the future of AI. This has been a fascinating deep dive so far.
It has.
We've explored the core benefits of IML,
Right.
delved into its really diverse applications,
Yeah.
and even kind of examined the challenges that lie ahead.
We have. And through this exploration, I think the overarching theme that emerges is the importance of this human-machine partnership in IML.
Absolutely. It's not just about building smarter algorithms. It's about creating systems that leverage both human intelligence and artificial intelligence to achieve, better outcomes.
Yeah. Precisely, IML recognizes that human insight and expertise are invaluable assets, even in the age of increasingly sophisticated AI.
It's about, finding that sweet spot where humans and machines can kind of complement each other's strengths and create something truly innovative.
And the synergy leads to more robust, more trustworthy, and more efficient machine learning models. It allows us to tackle complex problems that were previously intractable, especially in areas with limited data or where human understanding is critical.
It's like we're moving beyond the hype of AI and into this new era of, practical, responsible, and human-centered machine learning.
Exactly. And the research opportunities in IML are vast.
Yeah.
From developing new interactive algorithms and visualization techniques to establishing standardized evaluation metrics and designing intuitive user interfaces. There's so much exciting work to be done.
This deep dive has certainly given me a lot to think about. It's clear that IML has the potential to revolutionize the way we approach machine learning, making it more accessible,
It does.
more impactful, and ultimately, more beneficial to society.
I couldn't agree more. IML represents a paradigm shift in AI.
Yeah.
One that emphasizes collaboration,
Right.
transparency, and human empowerment.
And as we continue to explore the frontiers of IML,
Mm-hmm.
I'm confident that we'll see, even more groundbreaking applications
I agree.
and innovative solutions to some of the world's most challenging problems.
To summarize the paper, Interactive Machine Learning, a state-of-the-art review presents a comprehensive overview of the field, highlighting, the key benefits, applications, and challenges.
Right.
It provides a taxonomy of IML research based on merit, technical focus, and sectoral focus.
Okay.
And it really underscores the importance of the human-machine partnership
Yeah.
in achieving robust, trustworthy, and efficient machine learning.
It's a must-read for anyone, interested in the future of AI.
It is.
And the, kind of the evolving role of humans in an increasingly automated world.
Absolutely.
Well, thanks for joining us for this deep dive into the world of IML.
My pleasure.
Until next time, keep exploring and keep learning.